Alright. How are you guys doing? Alright, let's get this party started here. Today we're doing parametric equations. Let's start off with a little introduction about what exactly are parametric equations. To help us see that, it might help to indicate what is different about them as compared to other types of equations that you may be more familiar with. For example, take Cartesian equations. You're probably familiar with Cartesian equations. They look more or less like this. They have some x's like 2x, and they have some y's, 5y plus 3, some variation of that. The key characteristic to note from here is that you have a bunch of x's and they're equal to a bunch of y's, and then you might have a mixture of them, whatever. Sometimes you have x's on both sides. That's the gist of Cartesian equations. You often note that changing the value of x would affect the value of y if the two sides are to be equal. That's different in parametric equations in that you don't have this dichotomy here, x's and y's. Instead, you have a totally different setup. You have one central variable, often they call it t, and this guy's called the parameter, and then you have a bunch of equations that come from there. For example, you might have an equation that has x's. This equation would have x's and t's. You might have another equation that has y's. This equation has y's and t's, and so on and so forth. You could have as many as you want. You could have z's. You could have let me erase this. You could have x's, y's, z's, as many as you want, and in some sense it's a much more powerful way of looking at things than the Cartesian way. This has roots in problems from physics, where traditionally t is meant to represent time after some fixed point. For example, t equals 0, often called t naught, is the initial time. When you plug in t equals 0 into these equations, that gives you x values and y values and z values, presumably describing the position of some particle, the x, y, and z position. And so as you vary t, for example, after t, when t is equal to 1 second, you could plug them in there and get a different value for x, y, z, meaning a different position, possibly, for the moving particle. You can say, well, where's a particle when time is equal to 23 seconds after initial count? At 23 seconds, you would plug in 23 and get your position, etc., etc. That's the gist of it. That's how parametric equations are different. They share one common variable, and these equations come in singles, just one equation. This one could come in pairs or triplets or as many as you want. That's parametric equations. This is called the parameter. Okay, could summarize maybe. Let's see how that would look like. So let's clean this up. Yeah. So here's a summary. One single equation, usually x's and y's. Here's an example. Parametric, many equations. One common variable shared, called the parameter. Alright, let's go on and let's do some graphing of parametric equations, just for fun.